Hello and welcome to the ABCs of EJCs, Understanding and Solving Building Movement Problems, presented by Construction Specialties. Our presentation today will last approximately 30 minutes. During that time, we hope to give you a good understanding of building movement and how to approach expansion joint cover specification. To start with, a brief introduction to our company. CS is a privately owned group of companies founded in 1948 by Edward Hallock, with sales and manufacturing hubs all around the globe. We manufacture a wide range of high-quality finishing products for large-scale construction projects. We benefit from in-house test facilities along with a strong global group of experienced personnel. Our solutions for building interiors and exteriors include impact protection systems for walls and doors, entrance matting, expansion joint covers, architectural louvers, and solar shading. In today's session, we'll be covering the type of movement a building can experience, what expansion joints and expansion joint covers are, the importance of expansion joints, how to express building movement in specifications or inquiries, factors to consider when selecting your joint cover, the different types of joint cover available, fire barriers and other accessories, and finally, we'll look at relevant NBS specification clauses. Let's look at building movement. There are generally 4 types of movement an expansion joint has to allow for: thermal, which is usually seasonal and gradual; settlement, which tends to happen when the building is built and usually breaks down into 2 phases, just after the structure of the building is completed and then when the live loads are applied, such as furniture, machinery and people; wind sway, which is unpredictable, intermittent and can be quite significant; seismic, which can be very significant and is often multi-directional. Luckily, we don't experience earthquakes very much in the UK, but there are special joint covers available to combat extreme seismic movement if you need them. And now to clarify what an expansion joint actually is. It's a separation gap designed to accommodate the anticipated movement of a building. It runs right through the building, dividing it into separate structures, which can then move freely and independently. And it's worth mentioning that gaps often get wider on the upper floors of tall buildings to accommodate increased wind sway. And what is an expansion joint cover? It's a product designed to conceal an expansion joint, typically manufactured of extruded aluminium and/or rubber. The cover allows the building to move safely as designed, without damaging the structure. Much of this presentation is focused on EJCs for the floor, as that tends to be where most inquiries stem from. But we'll also talk about the products available for walls, ceilings and roofs. We're going to talk about a situation which illustrates why expansion joints should always be designed into a building. The Guggenheim Museum in New York is a building you'll all likely be familiar with. Designed by Frank Lloyd Wright, it was built using plywood molds and metal reinforcements and spraying gunite, a type of liquid concrete, through the reinforcing steelwork onto the plywood molds. This construction method gave the museum beautiful clean lines all around the structure, but there were no expansion joints designed into the building. Years of wind sway and building movement left this. All the pink lines that you can see are cracks in the facade, which came about simply because there were no expansion joints designed into the building. To fix the problem, a 3-year restoration program began in 2007. It cost an eye-watering $29 million and brought the museum back to its former glory, repairing the cracks by the use of elastomeric sealants, along with the installation of concealed expansion joint covers. They may not be everyone's favourite thing to think about when designing a building, but expansion joints are necessary. They will keep your building structurally sound and looking beautiful for longer. Let's move on to the best way to express movement and the different ways it can be conveyed by specifiers, contractors and manufacturers. To start with, what you see here is a very simple approach to horizontal joint movement. Looking at the left side of the slide, the normal joint width is the size of the gap before any movement has occurred. And just to say that although it won't always be possible, it's a good idea to confirm the gap width around the time that the EJC will be installed, to allow for the fact that some settlement and slab shrinkage will already have taken place. Then the minimum joint width is the middle of the slide, is the smallest width the gap will become. The maximum joint width on the right is the largest width the gap will open up to. With those figures, the amount of movement expected to occur can then be calculated, usually by a structural engineer. But how do you then express that movement? One way to express building movement, and the one we see most often, is a plus or minus millimetre figure. You can also express movement as a percentage or as a total overall movement. Different architects, engineers and manufacturers express it in different ways, but it's important to understand what each one means. If you interpret it wrongly, it could be very costly. For example, a 50mm nominal expansion joint with an anticipated expansion and contraction of 25mm could be expressed as 50mm plus or minus 25mm. 50mm with a total movement of 50mm, 50mm plus or minus 50%. The first way is the best, as it removes any potential for misinterpretation. This final slide in our Introduction to Building Movement illustrates 3 primary types of joint movement for floors or ceilings and walls. 1. Opening or closing movement typically occurs due to temperature fluctuations or material expansion and contraction. For example, concrete slabs expanding in summer and contracting in winter. 2. Movement resulting in a change of plane level on either side of the joint is usually caused by differential settlement, structural deflection, or seismic activity. 3. Movement along the joint length often results from lateral forces such as wind loads or seismic shifts. Now let's talk a bit about the factors that influence the selection of an expansion joint cover. Firstly, expansion joint width. What size is the gap you're dealing with? Secondly, anticipated movement on the horizontal, vertical and lateral planes. The structural engineer is usually the one to calculate these figures, and bear in mind that without this information, it's almost impossible to determine which expansion joint cover to use. We're going to look at the different types of cover available shortly, but so that you have something to go by, single gasket joint covers typically allow for up to 20% movement. Double gasket joint covers typically allow up to 50% movement. Metal joint covers can allow up to 100% movement. Then consider the building environment and the loading requirements. This is very important because different types of building and locations within buildings will have different requirements. Finally, the aesthetics will be important, but these sometimes have to come second to functionality, as there's no point having something which looks nice if it fails to do its job. And now we're going to delve into market sectors. Although there's no one model that suits an entire sector, we do see certain types being used and can draw on our own experience to help guide your specifications. In a hospital or other hygiene-sensitive buildings, gasketed expansion joint covers are the most popular solution. These are available in single gasket or double gasket models, depending on how much movement is required. These types of cover are flush with the floor and wheel-friendly, along with being watertight, so that cleaning fluids can't escape down any gaps in the floors and create a hygiene hazard. In heavy traffic area, like a school, leisure centre or office, in addition to secure environments such as prisons, you are more likely to need an all-metal joint cover, something that is hard-wearing, tamper-proof, and ultimately low maintenance. The data centre sector continues to expand, and the EJC specifications we've seen for these buildings are usually for all-metal models. Aesthetically, you can imagine why these suit their environments, but in addition, the heavy-duty nature of the floor models allow for any wheeled equipment to be moved around easily. For airports and other very heavily trafficked areas such as shopping centres or stadia, you are going to need a heavy-duty all-metal EJC. A product that offers 1 ton point loading, is happy being walked over thousands of times a day, and is suitable for heavy-wheeled traffic from luggage trolleys, forklift trucks, etc., will be ideal. Car park joint covers need to be able to cope with all weathers and be suitable for both interior and exterior use. They need waterproofing properties and they need to cope with regular vehicular movement. Generally, these joint covers have a 1 ton point loading capability and are made of extruded EPDM rubber, aluminium or stainless steel. We will come on to car parks in a bit more detail later, as it's worth digging a bit deeper into the requirements. That brings the look at market sectors to a close. Are there any questions at this point? The choice between surface-mounted and recessed system depends on project type, functional and aesthetic requirements, available budget, and in some cases, installer's capability. Surface-mounted systems are similar to install, have a lower initial cost, and can be replaced more easily if damaged. They are particularly suitable for renovation projects where cutting into the substrate is impractical. However, these systems typically have a larger visible surface and may be more challenging to keep clean. It's important to assess their suitability for high-traffic areas and ensure that the side profiles do not create a potential trip hazard. Additionally, surface-mounted covers depend on the strength of their fixings and may loosen over time compared to recessed systems. Recessed systems provide benefits such as flush finish for improved aesthetics and safety, as well as more secure installation within the substrate. They are often preferred in high-end architectural designs. The disadvantages include higher cost, more complex installation, and limited suitability for retrofitting without major modifications. If a recessed joint is selected, consideration must be given to creating a blockout. A blockout is a recess formed by cutting into or casting into the floor slabs to accommodate the frame of a recess-mounted expansion joint cover. When specifying, ensure you understand the product's frame depth so the cover can be integrated correctly into the floor design. For new build projects, it's best to provide the slab manufacturer with the blockout dimensions so they can incorporate them during the casting process. Keep in mind that if the wrong blockout size is specified, or worse, if it is overlooked entirely, correcting the issue can cost the contractor or client more than the entire EJC supply and installation. For refurbishment projects, customers typically prefer surface-mounted options for minimal disruption. However, in some cases, this isn't feasible, and removal and replacement work must be required to accommodate a recess-mounted solution. Let's start with floor joint covers. Single gasketed floor joint covers usually come in surface-mounted and recess-mounted options. They have minimal exposure surface, and you would normally use this type of joint cover internally. They're usually designed for joints of up to 50 mm with an expected movement range of up to plus or minus 10 mm. Most manufacturers will have a standard range of gasket colours to choose from to help the covers blend in with the surrounding floor, wall or ceiling finish. They can generally be used in conjunction with carpets, wooden floors, terrazzo tiles, vinyl, ceramic tiles and stone. This video shows how a recess-mounted, gasketed expansion joint cover operates under movement. You can see that the gasket is being compressed and stretched. Over time, the gasket may need replacing as a result of wear and tear, but we normally see a life cycle of around 10 to 15 years if maintained correctly. Double gasketed floor covers are generally only available in recess-mounted options. These types of joint cover are for use with joints of up to 135 mm in width, with a substantial movement range of up to plus or minus 38 mm. Some double gasketed covers are designed to incorporate the floor finish within the centre plate to minimise the visual impact of the cover, like the ones on the right of the slide. This is an example of a double-gasketed expansion joint cover in action. The floor finish has been incorporated into the centre plate to lessen the visual impact of the joint. Metal floor covers are generally for larger joints of up to 150 mm wide. They also have a higher movement range of up to plus or minus 100 mm, with some models offering multi-directional functionality. Certain models can close up to 100% as long as there is nothing else within the joint, such as a fire or moisture barrier or a turn bar mechanism. They provide a standout appearance, as you can see here. They generally require very little maintenance due to their durable construction, with very few, if any, perishable parts, and can be used outside if required, for instance in public plazas or on link footbridges. This short video demonstrates how a metal joint cover can open and close up to 100% of the joint width. You'll see a small spacer in the centre of the plate, which stops the concrete slabs actually touching and potentially cracking. And this video shows how a multi-directional all-metal expansion joint cover reacts during building movement. You can see how the different components of the cover work with the movement in the floor slabs. Moving on to cover strips, which are a very simple economical solution. These types of cover generally just push into the existing joint or are screwed into the floor on one side of the joint. These can be used on joints of up to 100 mm, with a variable movement range depending on the type of cover chosen. Note that cover strips with clips, like the first image at the top, won't be able to close as much as the one on the far right that's just screwed in at one side. These types of covers are great for out-of-the-way areas or areas with minimal pedestrian traffic. Next, we'll look at wall and ceiling covers. Generally speaking, there are wall and ceiling covers for all applications, from drywall to suspended ceilings and for most movement ranges. As with the floor cover models, there are gasketed and metal models, along with simple cover strips, and you can usually find something to complement the adjacent floor cover if conditions allow. It's worth considering these in your specifications at around the same time as your floor covers. That way you'll be able to achieve the best finish possible on the project, pulling all of the movement joint elements together and helping project delivery go that much more smoothly. And now to look at exterior wall joint covers, which are available for all vertical situations where new meets old and where weather protection is critical between buildings or parts of buildings. There are various types of cover available, including gasketed models, compression strips, top right, and foam seals, lower right. We see lots of requests for the concertina gasketed type, like the cover you can see in the main picture, but increasingly the compression foam seal is becoming popular. And now we're moving on to talk about roof joint covers. There are generally two types of expansion joint cover for the roof, metal and bellows. Metal roof joint covers, like the ones here, are generally low profile, paintable and durable, which makes them a popular choice. Bellowed roof joints grow in height and width, depending on the movement experienced. They are usually only available in black or white, with a variety of membrane and flange materials. They're easier to transition than metal joint covers and can also be used in between buildings, for instance where a building is lower than the adjoining structure and you need a movement joint solution which also stops rain or leaves getting into the gap. There are many applications where a watertight system might be required, for example in sports stadia, where the fan seating is exposed to the elements and you have hospitality in conference rooms underneath, which you don't want getting wet. Some joint covers, like the one on the bottom right, have integral water seals which tie into the building's waterproofing system, providing a completely watertight seal. These covers can generally be used in joints of up to 100 mm wide and can allow for movement of up to plus or minus 60 mm. Another type of waterproof joint is bonded compression seals, top right. They're completely watertight and don't require a blockout. The grooved sides hold the adhesive and create a stronger bond. These can be used in joints of up to 100 mm and can allow for up to 50% movement. As mentioned earlier, car parks present one of the most challenging environments for expansion joint covers. Both rubber and metal systems are available, but it's important to understand the key features to ensure long-term durability and performance. Car park joint covers must be specifically designed for vehicular traffic, with adequate loading capability, typically a 1-ton point load or more, resistance to live load deflection, chemical spillages, and extreme weather conditions. They must be robust and watertight. For joints up to 100 mm wide, rubber seals or gasketed systems can be specified. Traditional rubber seals, which consist of a compression seal with small wings and rely elastomeric concrete poured over the top for bedding, can be difficult to install correctly. Additionally, the concrete is prone to deterioration over time. More advanced solutions incorporate substantial integral rubber wings, offering superior durability. When specifying seals, it is essential to ensure compatibility between the adhesive or sealant used for bonding and the substrate type, and to double-check the recommended installation conditions. Some gasketed covers combine central gaskets with robust metal components and can be integrated with waterproofing systems. For larger joint openings or greater movement requirements, all metal systems can be specified. These typically are supplied with a moisture barrier as standard. To highlight the importance of correct joint cover specification, here's a photograph of a car park in Chelsea. As you can see, a very basic and inexpensive approach was taken. Metal sheets were simply installed over the expansion joint. Originally, both sides of these plates were bolted down. While this did cover the joint, it created a major flaw. As the building moved, the plates had no flexibility to accommodate that movement. The result? The metal buckled under stress. Notice here that one of the bolts has actually sheared off, leaving a sharp edge and creating a serious safety hazard for vehicles and pedestrians. A purposely designed car park joint cover would have provided a far more durable, watertight, and professional outcome in this situation. Expansion joints must allow for building movement, but that's not their only job. In many cases, they also need to stop fire, water, or noise. Fire barriers, moisture barriers, and acoustic barriers can all be installed within expansion joints, but it's important to remember that if the joint includes any type of barrier, it cannot close completely without damaging the barrier itself. This is often overlooked and can lead to failure. That's why barrier requirements must be considered right from the start when confirming movement criteria and sizing the joint. Let's start with fire barriers. As the joints go through the building, they may interrupt fire-rated floors and walls. To maintain the integrity of these elements, it is necessary to include fire barrier in the joint opening. Just as rated assemblies keep fire segregated to an area, fire barriers block the passage of flames from one room to another. An unprotected joint could create a chimney through the building, allowing fire to quickly spread from room to room. Fire barrier solutions vary. The image on the left shows a fire rope, a simple-to-install and compact option which is suitable to small to medium concrete floor and wall joint applications where movement is no more than 20% of the joint width. The other image shows a blanket-type fire barrier. This model is designed for floor and wall joints up to 500 mm and can cope with up to plus or minus 50% movement of nominal joint width. When specifying fire barriers, it's important to ensure that their performance was assessed in dynamic testing, which means that not only was the joint fire tested, it was also cycled to ensure that it would hold up to movement. To ensure proper functionality of the expansion joint cover system, it is also critical that the fire barrier dimensions are considered when determining the final size of the expansion joint opening. Joints should never close to 0 mm when incorporating a fire barrier because it needs space to move in order to function properly. For example, a 100 mm nominal joint opening should not be expected to close by more than half the joint width if a fire barrier is intended to be used. Please refer to specific manufacturer details for further information on recommended minimum opening widths. And a look at the other two types of barrier available with expansion joint covers. Acoustic barrier, seen in the top left, installed underneath an all-metal cover, is a flexible, non-reinforced mass-loaded vinyl. It resists the passage of sound waves and reduces the transmission of airborne noises. We see acoustic barrier being used between rooms in schools or recording studios and concert venues. The moisture barrier, bottom left, is generally supplied as standard on exterior joint cover models, but they can be specified as an extra where you might expect water ingress within an interior application. You can also specify an optional drainage assembly to help water drain away and avoid pooling in the moisture barrier channel. All that's needed now is information on how to specify. In the NBS style specification, the most common classification for expansion joint covers are PR_35_90_53_86 within Uniclass, and M10 for floor joints and K10 for plasterboard dry linings, partitions and ceilings within the common arrangement of work sections. A strong specification should include preferred manufacturer, product reference and required movement capability, frame depth for recessed models, confirm with the manufacturer how deep the frame is, blockout dimensions, essential to specify correctly as errors can be costly to rectify, accessories, fire barrier, moisture barrier or acoustic barrier if needed, be specific about fire rating and or acoustic performance requirements to ensure the correct product is delivered. Colour options for gaskets if applicable. We've covered a lot of information today, so just to summarise the main points. Expansion joints allow for safe movement of the building, and when specifying the covers, you need to do so with the building and its end users in mind. You should think about complementary wall and ceiling covers where required at an early stage, along with confirming any requirements for fire, moisture or acoustic barriers. The NBS reference are, according to Uniclass UK, PR_35_90_53_86, and in the common arrangement of work sections, typically M10 for floor covers and K10 for wall covers.